So when are zeros significant, and why would zeros not be significant in some cases? Well, let me give you an example. First of all, let's say you took an instrument and you measured a distance with that instrument. It's a stick. It's basically going to give you a distance in meters. And the distance you measure is 12 meters. Okay. Now, the 1 is a accurate number and the 2 is your estimated digit there. And so you have two significant figures there. And so you have 12 meters. Now, if I ask you to convert that distance to centimeters, your answer will be 1200 centimeters, because in each meter there are 100 centimeters. So 12 meter equals 1200 centimeters. So now you have four digits, 1200. Does that mean that suddenly the number of significant figures went up from 2 to 4? That cannot be the case, because the significant figures are directly obtained through the power of the instrument used to make the measurement. If you obtain two significant figures, conversion from one unit to the other, where you place zeros as placeholder zeros in this case, and that case here in my example would be the case of trailing zeros. Trailing zeros are not significant. And here is another example. If you have 100 as some measurement, only the 1 would be significant. These zeros are not significant. Now, what about here, 100 point? What if these zeros were obtained from the instrument? In that case, you have 100 and then you would put a decimal place there to specify that these zeros are significant, and now we know there are three significant figures. Trailing zeros are the zeros that appear without a decimal point. In this case up here, 4.70, it has three significant figures. Why three significant figures? Because this zero is not considered to be a trailing zero of that sort. It's not a placeholder zero. If you go back for a second and look at the ruler we use for measurement here, what if our length of this red tape fell directly on top of the 5? Would you report that as 5 centimeters? No, because the instrument can give you an estimation in the hundredths place in this bottom second case. Your report for the length would be 5.00 centimeter. So those 0.00 are required for the measurement to be accurate, and so those zeros are significant. They are not some part of conversion from one unit to another. Hence, as we saw here in 4.70, the zeros that show up after the decimal point, where there are numbers preceding those zeros, are significant. But here we have 0.0032. 0.0032 or 0.0032 only has two significant figures. Why is the case? Well, if you obtain a distance in centimeters, such as 32 centimeters, and you convert it to decameters, then you would have 0.0032 decameters. So those zeros are also placeholder zeros. They are leading zeros in that case. So those are the only two cases that you see here. This kind of leading zeros are placeholder zeros, and this kind of trailing zeros are placeholder zeros when zeros are not significant. In all other cases, zeros are significant, and any digit that's not a zero will always be significant. So here 7.314 we have four significant figures. 73.14 we have four significant figures. Here we have zeros, but because they are neither trailing or leading in the two cases we saw previously, these zeros are as well significant. So we have a total of 5 significant figures. And here are 4 different situations. I want you to tell me how many significant figures are in each one. Let's look at the first one. And pause the video and think about it. If you said there are 4 significant figures, you are right. How about here? Here as well there are 4 significant figures. Here, normally these zeros would not be significant if this decimal place would not have been placed, but because it is placed there, we have 3 significant figures. Finally here, how many significant figures? That's right, these last 4 digits, while this 0 as well as these 2 zeros are just leading placeholder zeros and they are not significant.